Okay, so we're going to look at sort of rounding all of this organic chemistry up that we have done into answering a possible exam question which causes students all kinds of difficulty. So we're going to use your organic chemistry to identify an organic compound with different functional groups. Okay, so we've been given 4 colourless liquids. One's an alkane, one's an alkene, one's an alcohol, one's a carboxylic acid. So we've got to explain how you carry out chemical reactions to identify each of those. And you've got to state your observations in each case. So you have been given the chemistry in the previous videos in your textbook notes, wherever you've picked it up, okay, in order to identify these groups. So let's see how we would go about it. So you really need to know your chemistry if this does actually come up. So let's see what we've got. We've got an alkane, we've got an alkene, we've got an alcohol, and we've got a carboxylic acid. So how are we going to identify each of these? So it did say we have to use chemical tests. So in other words, we're not allowed to burn them, we're not allowed to take pH. Now if we did want to burn them, let's say we were given license to burn them, right? We could probably do that. Carboxylic acids won't burn because they're solutions, so we'll not do that. Alcohols burn with a nice clean blue flame, okay, with a very faint yellow tip. Alkenes burn with that very sooty, so black, sooty flame, and they with a very orange colour to it. Okay, alkanes burn with a fairly yellow flame, kind of in between the alkene and the alcohol. Okay, so if you did want to burn it, you could probably do that. If you wanted to do pH, let's say, which again we can't do in this one, but we'll just remind ourselves of what it was. The only one we could really identify with pH paper or universal indicator is the carboxylic acid, which goes orange. All the others are pH 7, so pH wouldn't be much good to us there. So how do we do it then if we're asked for chemical tests? Well, let's first of all, I think, use the one that we did right back when we did alkenes, and we added some bromine water to it. Okay, and when we added bromine water, if you can remember, the only one that changes it was the alkene, and it goes from that sort of orange colour. And remember, always talk about the original colour to the final colour. Don't just say it goes colourless. So that goes from orange to colourless. The alkane just remains orange when you add the bromine to it. It doesn't change any colour. Don't say there's no reaction. They're looking for an observation. So no reaction would actually cost you a mark. The other ones here also will remain that orange colour. Okay, so both of those will remain orange. Now, there you go. So we have identified my alkene. Done. We know which one the alkene is. So we've got 3 more left. Okay, let's take the second chemical test that we looked at in the alcohols topic. So in this one, we warmed it with an acidified potassium, I'll just write potassium, POT, dichromate. Okay, and if you remember what happens to alcohols there, it goes from orange, and again remember, always quote the original colour. It went orange to green if it was an alcohol. Okay, alkanes, don't say no change or no reaction. Okay, our answer is the observation, and the observation of what we see with our eyes is that it stays orange. We've already done our alkene, but if it was still in the mix, it would also stay orange. And our carboxylic acid here will also remain or stay orange. Okay, I might write green, probably just to keep myself safe here. I would write orange solution actually to green solution. I don't think they'll pick you up on that, but we'll just keep ourselves right. Okay, how do we then, so we've got rid of our alcohol. What about our carboxylic acid then? Well, we have a couple of tests for our carboxylic acid we could use. We could add some solid sodium carbonate or whatever carbonate, magnesium carbonate, metal carbonate. Okay. There will be here, with our carboxylic acid, we will see some fizzing. We will see that fizzing will be a colourless gas. Okay, we should note the solid dissolving or disappearing. Okay, we should get a little bit of heat produced, and I think it would be really good to test the gas with lime water, and that gas goes milky the lime water goes milky when the gas is passed through it. And that's just identifying that the gas therefore must be carbon dioxide, so we know that our original compound is indeed a carboxylic acid. Okay? In the alkane has got no reaction with this. The solid will just settle to the bottom of the liquid alkane. Okay, now alternatively for your, I'm just going to rub out a bit of this stuff at the top here. Okay, alternatively for our carboxylic acid, we could use some metal, and magnesium would be a reactive enough one without being too reactive. Okay, what would we see with our carboxylic acid here? We would still see fizzing of our colourless gas. Okay, we would see the magnesium would disappear. Okay, we would see a colourless solution, and it would give out some heat. And the key thing is we would also take our gas and we would test it with a lighted splint. And because we should know our gas is hydrogen, we should get the pop. And that tells us we've definitely got a carboxylic acid. Over here, the magnesium will have no reaction. The magnesium will just settle to the bottom of the alkane. Okay, so that's quite that's really putting all of that chemistry together that we have done over the last while, guys. Now, in your textbook, there's a really good exercise in your textbook that I spoke about there just at the start, and you really should do these two exercises on page 217. You have your little test yourself and you show you can exercises, so I would advise you strongly to have a go at those. If this question came up in a GCSE paper, it's likely to be A, answered very badly, and B, to be worth quite a few marks. Okay, so hopefully that helps you guys.